So, what connects routers, switches, and devices? Network cables. There's a few different types of network cables. First, we'll talk about Ethernet cables. Ethernet cables plug into these jacks, which are called RJ45 jacks or ports. They're interchangeable. Here's a closer look at the two ends of an Ethernet cable. Ethernet cables have twisted wire pairs inside that are visible on the clear ends. In this example, both ends are the same, so this Ethernet cable is called a straight-through Ethernet cable. Straight-through Ethernet cables can be used to connect switches to laptops, to desktops, or printers, and even IP phones. So, IP phones use a different Ethernet cable connector, which has a smaller head called an RJ11 Ethernet cable. The RJ11 jack or port is much smaller than an RJ45, as the head of an RJ11 is much smaller. So these devices can be grouped together into what are called end-user devices. End-user devices are any kind of device that people use to access the internet or other digital resources. So straight-through Ethernet cables can also be used to connect switches to modems or Wi-Fi routers. And they can also be used to connect switches to routers. So in order for a straight-through Ethernet cable to connect a switch to another switch, the only way that's possible is if the switches have an auto MDIX feature enabled. This is the same case for router-to-router connection. They both need to have the auto MDIX feature enabled. Otherwise, straight-through cables will not work between switches and switches and routers. So for any routers and switches that don't have auto MDIX cables, if they don't have MDIX enabled, then the type of cable we need is going to be different. We need a cable where the twisted wire pairs at each end are different. So notice here how the colors of the wires are switched around at each end, right? They don't match. These type of Ethernet cables are called crossover Ethernet cables, as the wires are crossed over, not matching. So what can these crossover cables connect? Switches to switches, routers to routers, and computers to computers. Think of it as anything that is of the same type. So Ethernet cables can have different types that affect how fast data can pass through them. These Ethernet cables are labeled different cat or category numbers and letters. So Cat5 allows 100 megabits per second of data. That means 1 million ones and zeros of binary code per second, which is the slowest of the bunch. Cat5e is leaps better at 1 gigabits per second, which is the same as 1,000 megabits per second. So it's a lot quicker. Cat6 is 10 times faster than Cat5e at 10 gigabits per second. Next, we have coaxial or coax cables. Coax cables are electrical cables that are used to transmit high-frequency signals over long distances. They can transmit signals with minimal signal loss and are more resilient to physical damage, which is why coax cables are used for modems and cable boxes that need to connect back to an internet or cable service provider. Coax cables have a male and female end. The male end has a pin in the middle. The female end has a hole in the middle. So, see why they call them male and female ends now? Next, let's look at fiber cables. Starting with multimode fiber. So, multimode multi-mode fiber optic cables are used to transmit light signals over short distances at very high speeds. They are immune to electromagnetic interference since it uses lasers instead of electrical signals. These cables are good for high-speed communication systems, but are not as efficient at transmitting data signals over long distances as single-mode fibers. They are also more susceptible to signal loss due to bends in the cable, which is why they should be treated delicately. The reason why they are called multi-mode fibers is because they allow for multiple paths that the light can travel within the cable. So, multi-mode fiber is often seen with orange wires or aqua-colored wires. We also have single-mode fibers. So, single-mode fiber optic cables, like multi-mode fiber optic cables, are used to transmit light signals over long distances at high speeds. These cables are often colored yellow. They are more efficient at transmitting signals over long distances than multimode fibers, since they have only one path for the laser within the cable, causing less signal loss than multimode fibers, but they are more difficult to work with, requiring special equipment. They are also more fragile. Multimode fibers are less expensive. Single-mode fibers are way more expensive, which is why they are seen less often at companies. To connect fiber cables to routers and switches, we need special small form factor pluggables, or SFPs. These connect device ports. So these compact device ports are also called mini GBICs because they are smaller versions of the gigabit interface converter, or GBIC, which was an earlier version of the device port used for connecting network equipment to fiber optic cables. So these SFP or mini GBIC devices are also hot swappable, which means that they can easily be removed and replaced without having to shut down the router or switch. So there are multi-mode SFPs, which are usually denoted by a media type that states MMF for multi-mode fiber. And then there are single-mode SFPs that are labeled with the media type of SMF for single-mode fiber. So here's an image of how the SFP fits into empty slots on routers and switches. It's a long piece that slides into the empty slot. Fiber cables are already crossover cables. So reason being because they have lasers going one way on one end and the other way on the other end. So the ends already can't match. For example, let's look at this fiber cable end. One side of this piece is the RX, or receiver side, which is where it takes in the laser signal from a device. And because fiber connections are already designed to be crossover cables, we see here that the other end is a TX, or transmit side, where it sends out laser signals to a device. So again, seeing as they're already basically crossover cables, fiber cables can be used in any pairing. They can pair any device pairings. So that includes switches to end-user devices to one another, switches to routers, switches to switches, and routers to routers. So there are a few things that have to match in order for the fiber connection to work. So the first is the fiber cable type, so either single or multimode. The second is a fiber connector type, which can be an SC, LC, or ST connector. So LC connectors have a round shape and are often used in multimode fibers. SC connectors are square and are often used in single mode fibers. ST connectors are often used in multimode fiber cables and have a twist and lock mechanism called a bayonet style locking mechanism. Third is the fact that both devices need to be able to transmit and receive data at the same wavelengths of light. So the wavelength of light is the measure of the size of a light wave. So imagine a light wave as a series of hills and valleys, like a roller coaster. The distance between the two hills or the two valleys, right? So the distance here, they are wavelength of the light, right? So if the hills and valleys are close together, the wavelength is short. If the hills and valleys are further apart, then the wavelength is long. So both network devices would need to be able to receive and transmit the same types of wavelengths for the connection to work. Fourth is the fact that the network devices must also be able to receive and transmit the same speeds. And then fifth is the fact that the network device must be able to send and receive the light signals from the same light source. So that can be an LED light or a laser. Finally, sixth, there is the optical modes or OMs of the fiber cables themselves. An OM refers to the way light travels through a multimode fiber. There are currently 4 main types of multimode fiber OMs available. So OM1 fibers are the oldest and least expensive type of multimode fibers, which with speeds up to 10 gigabits per second. OM2 fibers are also have speeds up to 10 gigabits per second. So OM1 and OM2 are used for longer distances. OM3 fibers are newer with speeds of up to 100 gigabits per second. OM4 fibers are the newest and highest performing with speeds of up to 100 gigabits per second. So OM3 and OM4 are faster, but are used for shorter distances. So in summary, in order for fiber connection to work, you need matching fiber cable types, right? You need the OMs and connectors to match, as well as the device configurations for speed, wavelength, and light source. For your computer to connect to a switch in order to configure it, there's a different type of cable you need. The cable used to configure and connect routers and switches from your computer are called console cables. So console cables have one end that connects to your computer. In this case, the end is a USB. The cable's other end connects to the router or switch. In this case, that connection is an RJ45 Ethernet connector. So here's an example of how this cable's USB would connect to your laptop, right? And the RJ45 piece would connect to the console port on the back of the switch. Notice here is the console RJ45 port being used to administrate and configure the switch using your laptop. There's another way you might see console cables working. In this case, the console cable is made up of a few different connectors. First, we have the USB, which connects to your laptop. Then you have the other end of the cable, which is an RS-232. Since this RS-232 won't connect to a router or switch, we need another cable to translate the signals. That is why we have the DB9 connector to connect the USB to RS-232 cable to our new cable here, which has the RJ45 connector. So before you can use this type of cable, you have to make sure you download the proper drivers to your laptop, which are software programs that allow your computer to communicate with these different types of hardware devices. The driver acts as a translation layer between the cable hardware, right? Cable hardware and your computer's operating system. So make sure you download the drivers for the cables from your cable manufacturer so the cables will work with your PC. Let's look at how exactly your laptop is able to connect to a switch or router. So we know the USB side of the console cable connects to your laptop, and the RJ45 side connects to the console port on the router or switch. So once connected, we need to see the communication or COM port the cable is connected to on your laptop. That is why we need to open Device Manager on your laptop and see which COM port was assigned to the USB serial port. In this case, it's COM3. Now we have to open up a terminal emulation program like PuTTY, which is a free open source application that allows you to connect to the command line of remote computers as well as network devices. You could connect to the network devices either through the console cable or through SSH sessions, which we'll get to later. For this scenario where we're using the console cable, so we'll type in COM3 as a serial line, and we'll select serial as the connection type. A serial connection is a communication link that transmits data 1 bit at a time over a single line. So this is different from how regular Ethernet cables work, because Ethernet cables use parallel connections, meaning they transmit multiple bits of data at the same time over multiple communication lines or channels. So once you're connected to the switch, in this instance, you'd see the switch's command line interface. As a taste of what's to come, here's the command EN, which is short for enable. The enable command allows users to access user exec mode, which is a mode that allows users to perform basic tasks and view different device stats while preventing the user from performing unauthorized changes to the device's configuration. Then we have the configure terminal command, or config-t for short. This command lets you access configuration mode, which is where you can make changes to the configuration of the switch. Let's quickly summarize what we learned about network cables. We have Ethernet cables, which use electrical signals to transfer data. RJ45 port jacks are what Ethernet cables plug into. You can use Ethernet cables to connect switches to end-user devices, switches to modems, and Wi-Fi routers, as well as switches to routers. If you have auto MDIX or a crossover Ethernet cable, you can also connect switches and switches or routers and routers, essentially devices that are of the same type. Then we have coax cables. One end is male, while the other is female. Coax cables are used to connect modems back to the internet or cable service provider's location. Next, we have multi-mode fiber cables, which are usually denoted by an aqua or yellow color. Fiber cables use SFPs, also known as mini GBICs, that slide into the router or switch in order for those devices to accept fiber cables. Fiber cables can be used in any pairing as they are already essentially crossed over, with one piece of an end transmitting light signals and the other piece of the end receiving light signals. Lastly, we have console cables. These are used to connect your laptop to a router or switch so you can configure it.